thank you everyone for joining us. We're going to go ahead and begin our program. It's great to see so many friendly faces here on the call, as well as some new faces. So thank you all for joining us for our IE Data Summit event, with this event's topic focusing on environment, climate, and energy. Right now, I'm going to go ahead and pass it to my co-host, Erin Conlisk, who's on our research team here at the Center for Social Innovation. Erin?
Thank you, Sarah. To get us started, we are going to first go over some quick housekeeping items. First, please introduce yourselves in the chat. Feel free to share your name, your organization, where you might be zooming in from today. Use the opportunity to network with your colleagues around the IE and beyond. Second, please remember to keep yourself on mute to minimize background noise so that everyone can hear our wonderful presenters today. And lastly, as much as possible, please try to stay present during the summit. We have a tight schedule with lots of information coming at you really quickly. If you miss something, it might be hard to catch up. And back to you, Sarah.
Thanks, Erin. So next slide, Eric. Again, thank you all for being here. This is our third IE Data Summit event. The purpose of these data summits come from an observed need to democratize data and allow a space to share insights and resources, support each other in our work, and help produce better decision-making on investments and policies. In our event feedback forms from our previous data summits, environment was requested overwhelmingly as the topic for this next data summit. We see discussions taking place on the urgency to take action on environment, climate, and energy on the national, state, and local levels. Locally, there's been a lot of work done in the climate space, from the work here at UCR CSIR, Salt and Sea Task Force, OASIS, and the new CARB facility. There's also been a lot of work done locally from many organizations here on the call today, such as other academic institutions, nonprofits, government agencies, and some of who we'll hear from today. On the federal and state levels, there's been many investments and funding opportunities made available to take on more climate action work at the local level. And we hope that this information presented here today can serve as tools and resources to leverage those dollars for our region. So our first data summit, one of the data tool demonstrations presented was from CalEnviroScreen, a tool that shows pollution burden in indicators of environmental impacts. Feel free to follow the YouTube link that's going to be dropped in the chat to see the recording of this from our first data summit. And also in our first data summit was another data tool presentation on Warehouse City, which is a data tool that shows logistics industry footprint in the IE. The link for that will also be dropped in the chat, and you can find this data tool demonstration near the end of that recording for that research showcase portion of the event. And then in our most recent data summit, our health data summit, there was many different health organizations locally in the region that shared their recent community health needs assessments, which highlighted health effects from environmental impacts in different IE communities. And you can see this recording by also following the YouTube link that's going to be dropped in the chat. So from your feedback and from the previous information shared in other data summits, the need and urgency to focus on environment, climate, and energy for this data summit was evident, and we're happy to expand on this topic today. I'll pass it back to you, Erin.
So our data summit events are brought to you by IE RISE and UCR Center for Social Innovation, or CSI. IE RISE is a network of organizations united in the commitment to an inclusive, sustainable, and equitable future for the IE region. If you're interested in becoming an IE RISE member and participating in monthly events to network with other IE leaders, please email Damian O'Farrell at Parkview Legacy Foundation. His email is there on the slide. The Center for Social Innovation, or CSI, is a research center out of the University of California, Riverside, or UCR's School of Public Policy. CSI focuses on coalescing and synthesizing data and research in the Inland Empire. Based on the evidence, we talk about the IE region as a place with high educational and economic potential in what we call an asset-based narrative. One upcoming project that really emphasizes the opportunity to leverage these assets is our IE 2030 Vision and Roadmap Project, or IE 2030 for short. We are launching this project in the upcoming months with the environment as a central focus. IE 2030 has assembled over 20 organizations and leaders across the IE focused on inspiring a vision for success, addressing major issues affecting our communities, and creating a roadmap for achievements by 2030 and beyond. If you're interested in getting involved in the IE 2030 work, please email Eric Calderon, who's running the Zoom for us today. Thank you, Eric. From our CSI team at Eric Calderon at UCR.edu. So right there on the slide. Thank you. And I'll give it back to you, Sarah.
Thanks, Erin. And so one last data initiative that we're going to show you out of CSI and IE RISE is our research portal, which we launched from our first data summit this summer. And to give us this overview, I'm going to turn it over to CSI's Assistant Director, Eric Calderon. Eric?
Thank you, Sarah. And hello, good morning, everyone. Just wanted to quickly share, we do have a research portal up on our ierise.org website. We kindly ask people to take a look, log on to our site, and I will quickly share how it looks. The main purpose is to really just have one central location that can have and house and host many different research reports, data tools, and other projects that might be of use to our community. We understand that data is very important, especially out here in the region this large. So we kindly ask folks to please help us out in filling out this dashboard, this portal with additional research entries. And yeah, please feel free to take a look. It is a repository of different issues such as transportation, climate, criminal justice, health and well-being, economic development. So please feel free to take a look at the many different reports that we have highlighted here, including those that we have presented during our past data summit. But yeah, I'll drop a link in the chat and I'll kick it back to Sarah. Thank you.
Thank you, Eric. And now to give us a brief overview on CSI's research mission and values is CSI's research manager, Gary Rettberg. Take us away, Gary.
Awesome. Well, thank you very much, Eric and Erin and Sarah, for putting this event together. My name is Gary Rettberg. I'm the research manager at the center. And I'm just going to do a quick overview of some of our research and kind of how we approach it. So that can be the next slide, Eric. So at CSI, we have a framework that we've developed called DNA, and that stands for Data, Narrative, and Action. And this framework drives a lot of the research that we do and also kind of how we conduct that research. So our goal is to gather and analyze data in order to help tell a story or a narrative, as you could call it. And as you know, without a good story, data are just kind of numbers and stats. So once we've crafted what a narrative might look like based on the data, we would then present it and package it so that our community partners can then use that data and narrative and translate it into action. So, for nonprofits and community organizations, data is a really powerful tool to have, not only for grants and funding, but to also understand, the current landscape of whatever sector issue they might be working on. And one thing that we also believe is very important is to highlight and lift up all the great assets that we have in the Inland Empire. Erin talked a little bit about this, having an asset-based narrative as opposed to negative framing around problems and deficits. So, of course, it's important to acknowledge our challenges, but we also need to lift up the important work that's already being done and ideally invest more in that type of work. Next slide, please. So we're not going to talk about all the reports because we have a lot, so you can check out the website, but here are a few the type of reports we do. They're kind of generally all mixed methods, meaning that we analyze the quantitative data, but we also like to go out into the community and talk to people to better understand what's happening on the ground. That way we see if the data matches what we're hearing, or maybe if there's something important that we have missed, that the data might not show us. So I don't want to take too much time, but we will be producing more research and reports in the upcoming year. And we're always interested in partnering with organizations that have similar interests and values. So please feel free to reach out to me or any of the CSI team members if you'd like to follow up or if you have any questions. And my contact info is on the very next slide. Thank you all.
Thanks so much, Gary, for giving us that overview. There's Gary's email there. If any of you have questions or like to find out more about our work at the center. So that is now going to bring us into our research showcase portion of the event. And we have many speakers today, each giving back-to-back 5-minute presentations on their work, making this a very tight program. Unfortunately, there will not be time for questions at the end of the presentation, but please feel free to drop any questions that you may have into the chat or email our presenters. And this research showcase will provide an opportunity for researchers, policymakers, and community members to present their research work and findings to allow for a more direct personal connection between the data and how it can be used. So to start us off for our research showcase presentation, first we have Dr. Susan Phillips from Pitzer College and director of the Robert Redford Conservancy to talk about her recent report, A Region in Crisis, the Rationale for a Public Health State of Emergency in the Inland Empire. Susan?
Hi there, thanks so much. Just to thank you at UCR, CSI, IE RISE, and the colleagues for being here today. Would love to see my slides up. Thank you, that's perfect. And I also wanted to thank my own colleagues and collaborators. This is not just my work. It is the product of a very intensive long-term collaboration that we've had going on. In general, the Redford Conservancy really works with, in the space between environmental science, social science, community-based research, and into activism and advocacy, not unlike the DNA model that Eric just outlined. What we want is to benefit communities in the region as a whole and to think regionally about climate resilience, carbon emissions, et cetera, so that everything we do is basically under an umbrella theme of land use and climate justice. And you can see how important that issue actually is in the Inland Empire in particular. Next slide. So we've nurtured a set of partners we've been working with and really have a very justice-based active focus in fighting environmental racism and disproportionate impacts. So can you go to the next slide, please? One of the things we've been doing for about the past year and a half is thinking a lot about warehouses and doing a lot of mapping and charting of how land has shifted from open and working lands to industrial uses, and to think about the kinds of mapping and data visualization and storytelling that can amplify community voices, work toward justice, and like what can make a difference. And I think what we've learned is that it's really about gathering together the right statistics in the right ways and creating sort of visualizations that maybe people haven't seen before. So how can you think regionally and cumulatively about something like warehouse development when each decision is made, sort of at an incremental project level or municipal level? So there's a really dizzying set of statistics around a map like this one. We have about 4,000 warehouses in the Inland Empire. They generate, and this is from the report, they generate about 600,000 truck trips per day. And if you can imagine, there's a tremendous CO2 output, 50 million pounds of CO2 a day, 100 million pounds of NOx, 1,000 pounds of diesel PM per day. And over a period of a year, this adds up to some pretty staggering numbers. Can you go to the next slide, please? All of these things are in a report that we created. Amparo Munoz, Mike McCarthy, Marianne Ruiz, the Sierra Club, along with CCAJ, which was the lead on this, and 60 different organizations decided to sign on. We gathered a lot of analysis and information and put these new visualizations and maps into a well documented report that was embedded in the academic literature because we wanted it to be a little bit bulletproof, if possible, which is of course impossible. But there's a lot in there. Happy to drop that link into the chat. We sent this region in crisis to the governor, the attorney general, and the superintendent of schools to ask for various interventions. The first of which is a regional pause on warehouse construction so that we can identify communities of high saturation, environmental justice communities, and disadvantaged communities. And those are the ones that are often, subject to continuing patterns of environmental injustice. And I'm out of time. If you could just go through this, this is a map of schools in relation to warehouses. Can you go to the next slide? And just scroll through that. This is land use changes that have happened. This is Fontana through time. And you can see that residential areas have been gradually shifted to industrial land uses. Right across the southern street there is Harupa Avenue. That whole thing is neighborhoods. Keep going. So there's one little pocket of remaining neighborhoods go ahead and go to the next slide. So we've calculated, this is the work of my student, Kat Gelsley from Pomona College, how much land conversion has taken place. And this is a really difficult thing to quantify. You can read the statistics for yourself and go to the next slide. The question is, how does this enormous footprint not only affect our air quality and the health of communities, but how does it in fact impact the ability for us to be a climate resilient region? You can see that the hotter areas here are all the warehouses. The warehouses create a lot of heat. They're very, very carbon intensive. Last slide. There's also tremendous impacts on biodiversity and a lot of other issues to investigate. This is a little burrowing owl, and thank you so much.
Thank you so much, Susan. That was exciting, devastating, but exciting. And I hope to reach out to you. That was great. For our next presenter, we have Chris Gray, Deputy Executive Director of the Western Riverside Council of Governments, to discuss two reports, the San Bernardino County Vulnerability Assessment and the Western Riverside Adaptation and Resiliency Strategy, Part 1 Vulnerability Assessment. So on to you, Chris. Thank you.
Thank you, Erin. Next slide, please. I'm here today to talk about some work that WRCOG in conjunction with the San Bernardino County Transportation Authority has done. And it's really to map out regional climate hazards and identify a number of strategies our cities can use to implement to address these issues. Next slide, please. So what we developed is what we called the Resilient Inland Empire Toolkit. The goal was to allow first of all, to map out a variety of climate-related hazards throughout the region, and with the ultimate goal towards the integration of climate adaptation planning into the local planning processes, which would be things like general plans, specific plans, and other documents developed by our local agencies. And this was a project that was funded through a state grant from Calderon, so I wanted to thank them. And then a link to all of our materials is provided here on WRCOG's website. Next slide, please. So as I said, it was developed by WRCOG and SBCTA, and we followed a number of state guidelines in the development of these documents. Next slide, please. So our toolkit really has six main elements. There are introduction, vulnerability assessments. We also did evacuation mapping, adaptation strategies. We also developed a guidebook for building climate resilient infrastructure and a resiliency template. Next slide, please. So first of all, we've mapped out all of the climate-related hazards. These include flooding, wildfires, and the like. Next slide, please. We prepared detailed evacuation mapping for each of the cities in West Riverside County and San Bernardino County as well. And what we found out that there were a number of instances in which transportation infrastructure, which is needed to evacuate, could potentially flood or be threatened by other climate risks. Next slide, please. We developed a number of adaptation strategies that agencies could use when they develop their various planning documents. Next slide, please. We also developed a guidebook to give specific strategies on how cities can design and maintain transportation infrastructure, specifically roadways, transit facilities, and other types of transportation infrastructure to make them more resilient to climate challenges. Next slide, please. And then we developed a resiliency template for as cities update their safety elements or general plans and other documents, they can take they can build on this template to take action, which is more specifically tailored to the cities. So next slide. So I just wanted to thank you all. It's a very brief overview of the work that we did. And if anyone has any further questions, please follow up with me after the meeting. There's a link to all of our materials are on WRCOG's website. There is a link in our website to those materials. And if anyone would like to see them, please feel free to do so. Thank you.
Thank you so much, Chris, and thank you for all your work at WRCOG and your partnerships with San Bernardino County. So for our next presenter, we have Dr. Francesca Hopkins, Assistant Professor of Climate Change and Sustainability in the Department of Environmental Sciences right here at UCR to discuss her most recent publication, Reductions in California's Urban Fossil Fuel CO2 Emissions During the COVID-19 Pandemic. Francesca?
Well, thanks so much for the invitation to speak. Can you go to the next slide, please? So I think Susan did a great job setting up my talk where I'm going to talk about mapping fossil fuel CO2 emissions in Southern California. Next slide, please. Because now you've already seen this map. This is from the California EnviroScreen. It's the diesel particulate matter emissions shown in this map with the darker blue colors showing places with higher levels of diesel particulate, and then the lighter colors are lower levels. And so it's pretty clear that most of the diesel particulate is coming from the ports and our major interstate highways, which is related to both the logistics industry and transportation, which is not just a source of diesel particulate matter, but it's the biggest source of CO2 as well in our region. And so to me, really decarbonization that the state is undergoing is an opportunity for us to address environmental justice issues in addition to decarbonizing our economy. And probably this group already knows that exposure to air pollution falls strongly along economic, racial, and educational lines. And this map, you can see that there's very fine scale differences, even within a city, to exposure to diesel particulate matter. And so it's something that we need to start paying more attention to, this very fine scale. Next slide, please. So what my group did is we have a mobile laboratory, so it's a vehicle that has fast response greenhouse gas analyzers on board, and we can make measurements as we're driving. And so a student, Cindy Yanez, made some really cool measurements, just measuring CO2 on roadways in July of 2019, July of 2020, and July of 2021. And that's what's shown in these maps here. These are the locations she measured. And the CO2 enhancement we saw on those roadways is shown by that color bar, where the more purple and red colors are higher levels of CO2 and the yellow colors are lower levels. And so there's definitely some interesting patterns across the regions, but the most important thing we saw here is that, of course, in July 2020, there was a big reduction in on-road CO2, which we know is related to COVID-19, causing way less traffic. Many more people were working from home and reducing the amount of CO2 being emitted from roadways. Next slide, please. So that's important, but the roadways aren't necessarily where people live. So we wanted to take a closer look at actually where people were living. And so what we did is we used a really cool technique where we measure the radiocarbon content of plant samples, which is an index for how much fossil fuel CO2 that plant was exposed to while it was growing. So what we did is, again, we were in COVID-19, everything was still shut down. So we asked community members to send us grasses that we were growing near their houses. We actually were looking specifically for invasive grasses like Avena that's shown in the picture on the right side of the slide here. Citizen scientists, community scientists sent us these grasses by mail to my colleagues at UC Irvine who analyze the radiocarbon content. And that allows us to map CO2 from fossil fuels. So what you can see in the map on the left is the state of California. Each of those dots is a location of a sample that we received. And then the color bar underneath is showing the amount of fossil fuel CO2 in the region. And so clearly the two urban areas of our state stand out really strongly. And we think that this is a really good proxy for exposure to roadway pollution. So if you look at the graph in the middle, you can see that there's a strong relationship between the distance to a major road and the fossil fuel content, where the closer you are to the road, the higher the fossil fuel content as interpreted from this radiocarbon data. Next slide, please. And so we wanted to look even further and to see, we saw these big changes that happened during the pandemic. How is the recovery to the pandemic happening? So we asked many of those same community members to send us grasses that grew in 2021. And that's what's plotted here. We're comparing the San Francisco Bay Area, again, with each sample shown by a dot, to the LA metro area. And the first thing you can see is that let me explain the colors. So the blue colors are places that stayed about the same or got a little bit cleaner in 2021 relative to 2020. The red areas got dirtier, more fossil fuel CO2. So the first thing to notice, especially if you look in the Bay Area, is there's high heterogeneity. So that's really telling us that there's fine scale emissions that are affecting these samples. But then when we look more broadly at these two regions, you can see that the Bay Area generally stayed as clean, if not a little cleaner in 2021, whereas the LA area, especially centered near downtown, had a huge rebound in fossil fuel CO2. The IE is a little more mixed because, as we know, there's a lot of warehouse traffic that continued through the pandemic. But it's showing us really that, this experiment that COVID-19 gave us showed that there's really big differences across the state. There's differences at a very fine scale that I don't have time to show you today that we need to pay attention to. Next slide, please. And I'm just going to wrap up. So I think, we really need to link CO2 emissions and air quality to make sure that decarbonization is going to have an optimal benefit for air quality. Thank you.
Well, thank you, Francesca. Fun fact, my first semester as a graduate student instructor, I was the instructor of a young Francesca Hopkins. So I taught her everything she knows, or at least I didn't make chemistry so miserable that she gave up. So thank you, Francesca. That was really exciting to see. You've come a long way. For our next presenter, we have Jeff Mosher, General Manager from the Santa Ana Watershed Project Authority, to discuss their agency's report on Santa Ana River watershed community water experiences and ethnographic strengths and needs assessment.
So thank you, Erin. This is Jeff, and if you can go to the next slide. And I also want to mention that Rachel Gray, who's our water resources planning manager, is also on the call, and feel free to follow up with either of us. Because one of the messages that we want to bring is that as a watershed authority, we need to branch out with different stakeholders. And so we're talking to a lot of organizations that you may not know us, and we haven't talked with you. And I think this presentation will highlight some of the things that we're doing. I'm not going to talk about the water projects or all the good work we're doing in terms of salinity management and brine and new water sources. We're doing a weather modification, which is cloud seeding project. I'm not going to talk about that, but this is an issue that is very important to us. That's really understanding disadvantaged communities and underrepresented communities as part of our planning process. So getting that into what we do in terms of planning, and I'll talk about that, and you'll get a better idea of how this is working for us. So if you can go to the next slide. So just a little bit of background on us. We're a joint powers authority. So we're a public agency. We have 5 member agencies. They're listed here in the color on the map. Our watershed is big, 6 million people plus, 2,600 square miles. It's over 3 counties, San Bernardino, Riverside, and Orange County. Our activities are associated with watershed planning. We are a forum for stakeholders. We also own and manage a brine line for managing salinity, but I'm not going to talk about that today. Next slide. So our disadvantaged community involvement program was funded by a grant from the Department of Water Resources. This is a high priority for them. And the goal of this grant was to look at disadvantaged communities and underrepresented, just how this is defined is kind of in flux. You know, disadvantaged community is based on median household income, but that's not the only way that we want to look at it. But we want to understand their needs. We want to develop water strategy and water resources strategy, address those needs. And we want to provide technical assistance, which could be money. It could be helping small disadvantaged communities that have their own water system to address their needs. I will mention that we have a regulator, the Santa Ana Regional Water Quality Control Board. They adopt a human right to water, which is overlays some of this work, and they're working on a racial equity resolution. So you can see the priority for our regulators in our state in terms of this issue. So we do have a web page, I listed it there, which has more information that you can go to. Next. So why is this needed, right? So in our watershed, 1 in 3 residents qualifies as economically disadvantaged, and we've mapped this for our watershed. And 1 in 5 residents is an immigrant or part of an immigrant family that may be facing increase in social hardships. And one of the things that got our attention, or at least my attention, was that 4 out of 10 jobs available, this goes back a couple years, only provided sufficient income for working families. So 6 out of 10 didn't. And I think that's reflected, for example, in a lot of the jobs that may be at warehouses, that sort of thing. Next. So we adopted this approach that is not new, but it's new to water agencies. And it's an ethnographic study. And the ethnology is really getting into the communities with the individuals and people who are there and talking with them one-on-one about the issue. So our civic ethnology report, and here's the copy of it, of the cover. So it mobilizes that local knowledge, right? And then the water agencies can design our programs and policies and planning to reflect not just their strengths, but their needs. So that's really important to us. And our partner on this, there was a number of partners, but the key partner was Valerie Olson at UC Irvine, and she's in their Department of Anthropology. Again, very new for us. Next. So just real quick, what was in this approach were 4 activities: engaging those local communities, using community organizations, listening, and now analyzing what we heard, and then doing report backs. We looked at different groups, which was important for us. Native communities, these diverse local communities, which could be DACs, but also elected official mutual water companies that serve DACs. Next. So let me jump in what we heard, right? So from the underserved communities, we heard things that I think everybody brings up, you know, concerned about homelessness, water quality, water management. But then we also heard things that was very useful for us that we don't necessarily hear: social dynamics associated with those communities, the need for open and green space. You know, we hear that in other places, but we don't necessarily hear it as part of our outreach. So I want to go to the next slide so I can get through this within my 5 minutes. So what did we hear from Native communities? Again, very interesting. Government agencies don't recognize or listen to Native people. That was almost universal. And you know, again, we've heard that, but it's useful for us to get this information into our process. The idea that there's a spiritual connection to water, you know, very interesting and, you know, very useful at understanding their thinking. One that I had heard before, but again, it's good to document. Native communities, they say, listen, we're not, quote, disadvantaged. We're, you know, we know what we're doing. We're sophisticated. You know, we're managing our issues. Don't consider us as disadvantaged, but do consider us as partners on these issues. So that was useful for us to hear. I'm not going to go through the rest of them, but they're here on the slide. So you can go to the next slide. And so what did we come out of it at a very high level, right? And again, this was in the ethnographic report that was developed for SAPA and our member agencies. So they have an interesting way of looking at things that are connections and disconnections, right? So there's issues here, but also things that maybe we're doing well. But the issues that came up through these disadvantaged communities, Native Americans, elected officials, small water systems, was the idea of managing our water resources well, or what we're not doing well. Water rates and costs came up quite a bit. That's not surprising. So if rates are rising too high, that can be a burden. So this idea of affordability is something we look at, but that's something that these communities is important to them. Communication, they basically said we don't communicate enough or we don't communicate in the right ways. And there's a lot embedded there, and there's a lot that we can do to improve that. And then frankly, water quality. They want to know that the water suppliers are a trusted source of information. They can be trusted in terms of the water quality, and that's not necessarily universal. So this was good for us to see on a high level. But again, we got lots of other granular information that we're going to be able to use in terms of incorporating this into our planning, other activities we do at SAPA, and providing information to our member agencies and other water agencies on underrepresented communities and disadvantaged communities. So I'll stop there. Thank you again for the opportunity to be here.
Thank you so much, Jeff. Thank you for, your outreach and collaboration with other partners and for all the work you do. So next for our program, we're going to continue on the topic of water. And we're going to turn it over to Thomas Hile, PhD candidate of Earth and Biological Sciences in the School of Medicine at Loma Linda University, and Nataly Escobedo Garcia, Policy Coordinator for Water Programs at the Leadership Council for Justice and Accountability, to present their research on assessment of tap water quality in mobile homes in Eastern Coachella Valley. Thomas?
I think Nataly is going to go first.
Good morning, everyone. My name's Nataly. As already mentioned, I'm a water policy coordinator with Leadership Council. Thank you for inviting us to join y'all. So today, what we're presenting is work that we did in collaboration with Thomas, Dr. Sinclair, and team on issues of drinking water in the Eastern Coachella Valley. Next slide, please. So to set some context for y'all, we work in the Eastern Coachella Valley, which is a region that has for decades have been disinvested in. We have major issues of affordable housing and access to clean water, and communities of color are usually led to living in unsafe mobile home parks across the Eastern Coachella Valley. So it's estimated that we have over 500 mobile home parks out here. And one of the parks that we focused on doing testing in was Oasis Mobile Home Park. It's one of the larger parks that we see out here with about approximately 1,900 people living in it. It's near the Salton Sea and very low income community. The estimate for MHI is about 17,000. Residents are majority Latinos, and many are Purepecha, which is an indigenous group to the Morelia region of Mexico. In 2019, the Oasis Mobile Home Park system was actually found to have had unpotable water. They had arsenic violations that were put in place by the Environmental Protection Agency, or the EPA. And since this park was cited, the EPA has actually cited at least 12 additional mobile home parks because of arsenic violations. The work that Thomas, Dr. Sinclair, and team did was actually instrumental in getting a second emergency order put in place by the EPA, and instrumental in bringing attention to the water quality issues in the ECV. Next slide, please.
Okay. In 2016, Dr. Ryan Alienza and California Institute for Rural Study found that in their survey that 38% of people in the Oasis Mobile Home Park drank tap water, which might be contaminated with arsenic. And also 30% of people complain of water turn off. These concerns trigger us to investigate the microbial contamination of drinking water in vending machine in the Eastern Coachella Valley, which is found in the next slide. Next slide. And our study published in the journal called Water Supply, where we found physical observation of vending machines that were covered with slime, biofilms, rust. And our molecular result presented traces of genetic materials of selected microorganisms that we have there. Here you can see on the slide: Salmonella, Listeria, Pseudomonas, Enterococcus faecalis, E. coli, Campylobacter. All of these were the genetic material were identified in the vending machines, which indicate that somehow they were present or some form of contamination of the vending machines. Next slide, please. So we also carry out a study in the Oasis Mobile Home Park, where a physical observation, we saw muddy yellow or brown water that came from the tap. And also on the next slide, you will see that next slide, we'll see that there is a wastewater overflow, which can implicate a cross-contamination because of the PVC pipe that were near the surface. Next slide, please. Next slide. So our next study was also published in a journal called PLOS Water. You can find it online for both publications. And we found that arsenic was 4 to 8 times above the acceptable EPA standard. Also, we found the same microorganism using a PCR technique, which are E. coli, Pseudomonas, Campylobacter, Enterococcus, Listeria, Salmonella, still in mobile home parks. So we think that to address the arsenic contamination in the Oasis Mobile Home Park, we should install or reverse osmosis filter need to be installed in houses to reduce the presence of arsenic in those samples. And also our result in general, we conclude that the water from the Oasis Mobile Home Park, as well as the vending machines, were not safe for consumption based on our studies. Thank you.
Wow, thank you, Thomas and Nataly. That, again, devastating. I'll reach out and see if there's anything we can do. So to conclude the research showcase portion of our program, we'll now hear from Jaime Alonso, Executive Director of Grid Alternatives IE, to discuss some of the great work happening in the IE to transition to renewable energy with their Grid Alternatives IE 2022 impact. Thank you.
Hi, good morning, everyone. You can go to the next slide. It just has my headshot and information. Thank you for having me. As was mentioned, I serve as the Executive Director for Grid Alternatives Inland Empire region. I've been in this role since 2019. At Grid, the Inland Empire for us consists of all of Riverside, San Bernardino, and even goes up, includes Inyo County as well. And it includes large portions of the ancestral lands of the Kuya, Chemehueve, Serrano, Tongva, Paiute, and Shoshone people. Our theory of change really anchors our work and helps us focus on which data points we track. At Grid, this really starts by naming the systemic problem that we're confronting. For us, the problem is our fossil fuel-based extractive economy, which increases economic and environmental inequities and damages people's health. But it also threatens all of us, all humanity, by worsening the climate crisis. And I think there's pretty overwhelming consensus, certainly among this group, about that fact. So we focus our actions on really building community-powered renewable energy solutions that benefit economic and environmental justice communities. This means our work is really about transitioning into an energy future that is more equitable and that can sustainably benefit everyone. There are different organizational strategies we deploy. I just cited one here. If we partner with tribal nations, public agencies, community advocates to craft renewable energy policies and programs that benefit economic and environmental justice communities, and more families can stay in their homes, free and burdened energy costs and the threat of environmental disasters. Next slide. You see here are the way in which we kind of measure our impact. It's through people, planet, and employment. We call this our triple bottom line. Here you can see the impact we've had since Grid IE's region was established back in April of 2012. The hyperlink at the top will lead you to a map that allows you to see where in the Inland Empire region we have installed renewable energy projects. And it really does go everywhere from Western Riverside County through San Bernardino, the high desert, up to Inyo County and all the way to the Arizona border, including a lot of work we've done in the Coachella Valley as well. Next slide. Focusing on last year, we served 245 low-income households, which we define as typically 80% AMI or lower. We installed projects on 3 community facilities, totaling an estimated $12.2 million in lifetime energy savings. These systems that we installed amount to a little over a megawatt of energy that will prevent over 18,000 tons of greenhouse gas emissions over the life of the systems. All of our projects integrate our workforce training program and provide trainees with opportunities to develop core installation competencies. This includes everything from racking, wiring, roof penetrations, safety and array layout, et cetera. And in 2022, we had over 200 trainees come through our program, one of our training programs, some as volunteers, some high school students, some as individuals really interested in switching careers into renewable energy. We tracked 17 individuals in 2022 who now have full-time positions in the renewable energy industry. What follows are the communities of focus. This is a non-exhaustive list. Just kind of wanted to put out kind of where we're focusing our efforts right now, some of the funding that we've secured. I want to draw attention to the Eastern Riverside County Greenhouse Gas Reduction Fund. There's a state incentive program that is essentially wound down last year that has been replaced with the Calderon screen, and that has really removed a huge portion of Eastern Riverside County from the availability to fund projects for low-income ratepayers. And so we've raised about $2.5 million in this last year to commit to that area. Additionally, wanted to point out some of our tribal partners that we've worked with in the coming year, definitely doing a lot more on microgrid and resiliency work. Next slide. Lastly, I wanted to share an important asset we're bringing to the Inland Empire region. Environmental issues, I think they have a cross section of different issues that we need to tackle, I think, and it's a tremendous opportunity. And one of them is really creating career pathways and diversifying our overall workforce in our region. So at the end of 2022, we launched the first phase of our Clean Tech Training Center. Here's some photos that kind of shows that launch. Data we track show that solar accounted for 45% of all new electricity generating capacity last year. And the residential segment continues to have a large share of that increase at about 43%. The Investment Recovery Act that President Biden signed into law last year is really expected to significantly expand investment in solar. And so the solar job market is predominantly really driven by residential installation and project development. So with the build out and launch of our Clean Tech Training Center, we will provide rapid hands-on training in solar to individuals who aspire to be part of the equitable energy transition we really hope to create, with plans to expand training into battery and electric vehicle service equipment, which we're securing more and more funding for. We are a logistics hub, and as was mentioned earlier, that has a lot of direct consequences. And so providing access to cleaner vehicles is part of our future, part of our work that we want to integrate into our solar installation trainings. With that, I'll say thank you for allowing me to share a little bit about the impact we had last year. In the coming weeks, we will be publishing our 2022 impact report, and I'll make sure to share that with Sarah so that she can share it with you all as well. And it should be available on our website. Thank you all.
Thank you so much, Jaime, for showing us some of the great work coming out of the IE on this topic, and showing the intersection with jobs as well. So that concludes our research showcase presentation of the program. So thank you to all of our wonderful presenters for sharing your insight on all of the work that you're doing in the IE in the climate and environment space. So we are at the time in our program now where we're going to transition into breakout rooms for some data tool demonstrations. So you see on the screen here the different data tools that we're going to be demonstrating today. So there's going to be 2 different opportunities for breakout rooms. We'll start the first one now, and you'll be able to select the first breakout room that you like to go to.
My name is Shruti, and I work as a web developer at the GIF at UC Berkeley. At the GIF, we work on several grant-funded projects with the California state aid agencies to provide public access to climate data and adaptation resources. And CalAdapt is one of our major projects that we work on. And the other project you may have seen is the California's Adaptation Clearinghouse. So today I'm going to demo CalAdapt. And I would like to start with a quick introduction to the platform, which some of you may be quite familiar with, and some of you may not have come across. And then we'll explore some of the tools and the content on the website a little bit in more detail. So just to begin with, what is CalAdapt? So CalAdapt is a website that has been funded by grants from the California Energy Commission. And if you're not familiar with the CEC is the California's principal energy policy and planning organization. And we also receive funding from the California Strategic Growth Council. So our main goal is to provide a way to connect adaptation practitioners or folks who need climate change data with the climate data from California that was produced and used as a basis for California's 4th climate change assessment. And our aim is to provide access to climate data in a way that's easy for people to access without, having to be totally familiar with how climate models are run or any of the behind the scenes, all the science, all the climate science. So we have a kind of a tripartite mission. One is to provide visualizations of climate data through graphical user interfaces, and allowing folks, providing folks ways to download climate data in different formats, like an Excel file or a shapefile that you can add to your GIS GIS software. And we also hope CalAdapt is a way for folks to learn about climate science. And this is increasingly a big part of our mission. So when you do use climate data for your adaptation work, you have the climate literacy necessary to do that. And we can talk about some of the data services and how to access them from the website. We also do a lot of stakeholder engagement and outreach, and we do like frequent workshops on what your needs are. So if you subscribe to our newsletter, you can keep an eye on any future workshops coming up. So I'll demo this local climate change snapshot tool a little bit more detail in a few minutes, but let's take a look at CalAdapt, the website. So you can can you see the website? Okay. And if you have any questions while I'm talking, please feel free to chime in and ask. Can keep this as interactive as we can get over Zoom. So you can find CalAdapt at cal-adapt.org. So our homepage, we're always adding new things and new tools on our homepage. So you might, in the next few months, things might move around a little bit, but essentially when you land on CalAdapt, what you'll see are some of our most visited sections of the website. And if you're new to climate change or new to working with climate change data, we highly recommend visiting our New to CalAdapt page. And we have a Get Started guide, which we've worked on with different state agencies, our funding partners, and our users. And we've developed some information on, so you can get like a quick background on how to work with climate projections on CalAdapt. And there are different sections here. There's like, if you go to climate data, you can kind of get a list of, what data sets CalAdapt includes. We also have a few best practices on using climate projections. And we work with climate scientists to come up with, this is content we worked with climate scientists on. And this is very specific to California. So we hope it might be of useful use to you when you start doing your adaptation work. We have, so these are, if you go to our climate tools page, there are multiple tools that look at the different data sets in using graphical user interfaces and charts, like maps and charts. We'll go into the local climate change snapshot tool in more detail later, but we can kind of, explore some of the other tools. One of the tools here is maps of projected change. So this tool shows how we anticipate that temperature will change through time compared to a historical baseline. And this is the historical baseline. This is like a 30-year average of the historical baseline. And you can look at different mid-century period and or end of century. And these are absolute values. You can also look at the same temperature projected long-term. This is the annual average maximum temperature. And so these are absolute values. You can also look at the change from historic and baseline. So if you look at that legend, the color graph, the colors correspond to different change in temperature in degrees Celsius. You can also compare two different, say, mid-century emissions and end-of-century emissions to see the difference between the two. So that's one of the tools. And we'll come back to this tool page.
I have a question. Sorry to interrupt
yes.
you.
Sure, no problem.
So just out of curiosity, what, so I just want to make sure this is clear. Is the majority of the data on CalAdapt forecasted or historical?
So we have both. We have historical climate data and we have future projections.
Okay, how far back?
So the data that was used, let me open up one of our tools. It'll be easier to. So the historical data set that we use is like a gridded climate data set, and that goes back to 1950.
Okay.
And so the gridded climate data set is, and actually for all our tools, if you scroll down, you can read more about the data sets that we're using. So the gridded data set is 1950 to around 2013. And our future projections that we use are from 1950 to 2100, 2099 or 2100. So those are the future climate projections.
Okay, thank you.
Yeah. Sorry. So let's see. We can also take a quick look at the download data page, and there are a lot of different ways of downloading data from CalAdapt. Each of the climate tool has ways to download data from within the tool. But if you are, if you have multiple indicators you want to download, or you want to download data from multiple locations, you can use our data download tool. There are all our the original climate data that we get from the researchers, which are in netcdf files, are on our CalAdapt data server. So if you're familiar, if you know what you're doing with climate data and you want access to the original data sets, you can grab the netcdf file directly. We also have a public API that you can use if you have programmers on your in your organization, or you are a programmer yourself and you're familiar with, you're working with APIs, you can use the API directly. We also have a couple of packages that others have developed, which in using R and Python, that you can use to work with the API.
I have another question.
Yes, sure.
Or actually, this is kind of a two-parter question, but I'd like to know, who was your intended audience for this website, and what are you hoping to achieve the audience will do with the data that you provide?
That's a great question. Thank you for asking it. So yes, I think that has always one of the challenges that we had, because there are a lot of different ways people interact with climate change data, and people have different levels of literacy about how to work with climate change data. And so what we've tried in building our tools is to provide access to all the data, but have some more guidance on how to use it. So the kind of from our funding partners, when we are funded by CEC and Strategic Growth Council, the CEC focuses more on the tools that we develop for the CEC focuses more on energy sector stakeholders like utilities and consultants who work with energy utilities. With the Strategic Growth Council, we've developed tools that kind of help more, local governments, adaptation planners. So we've also we also hope the tools will be useful for community organizers and folks who do advocacy work.
Yeah, so sorry to interrupt you, but so for example, I work for our local 211 here in the Inland Empire region, and I'm the data analyst, and I have a proficiency in geospatial data analysis. So when I do see, for example, the data tools or the download data that's available, first of all, thank you for providing an R package, because I was going to say my organization technically uses ArcGIS. And I noticed that the applications or the interfaces that you use on your tools is Mapbox. So I would maybe like to know what kind of made you decide to use Mapbox over other GIS interface tools, and what maybe, for example, you would hope community organizations might be able to do, because I think there's a proficiency level, right, between what local communities know about climate data versus what is kind of already existing in the industry or in the research group of, like all the experts and climatologists and everything like that. So I guess I'm just kind of trying to figure out, if this is something that if your intent was to kind of bridge that gap of knowledge between local CBOs like my own. And yeah, so I guess that was a lot. So I guess the first question is Mapbox over ArcGIS. Because I think our area focus, because Esri is in Redlands, we use ArcGIS a lot. So what does Mapbox have that's over ArcGIS?
Right. Yeah, that's a great question. Our main at the GIF, we are, I think the main reason for choosing Mapbox over ArcGIS was at the GIF, we work with open source data or packages, open source software. And we didn't want to be tied down to any particular, provider.
Yeah.
So that is the main reason for using Mapbox and other software packages that we use to develop our tools. But we definitely hear that, we see that, local governments have ArcGIS. They want to integrate all our data sets easily into their own ArcGIS organizations. And so that's something we've been working towards. So I think I haven't used ArcGIS recently, but from what I learned, you can bring a lot of these layers into ArcGIS, especially the ones, layers that we pre-calculated. Getting like time series data is a little more challenging from, we store the time series as GeoTIFF at the back end. And so getting that data is a little more challenging in ArcGIS.
Right.
We do have a package, I believe it's the Caladapt Pi package is a extension that I think someone at UCANR worked on that works with ArcGIS Pro. So you can check that out, and that might, it works with Python and ArcGIS. So you might be able to use that one to get the data from Caladapt.
Yeah, excellent. Thank you so much for your guidance on that. Because I'm kind of just seeing off immediately that there isn't a straight, because I know every program, like even Google Maps and everything, has different shape files, or the shape files I think is an ArcGIS term maybe. But so okay, that's good to know about the file adaptability. So thank you so much.
Sure. Let's take a look at the local climate change snapshot tool. So this is one of the tools. This kind of came about because in the stakeholder engagement work that we did, a lot of over the past few years, we heard that some of the other tools on Caladapt are great, but they're too technical for a lot of users because they're like too many parameters you can customize, too many knobs to turn. And so when someone's new to climate change data and they land here, it's too overwhelming. So we designed this tool to be more pared back. It designed to be more straightforward, introductory, and accessible, and in particular support like adaptation planning in city and county governments and in community organization and advocacy work. So when you first open up the tool, what you're greeted with is this paragraph on top. It kind of highlights some of the general anticipated impacts for climate change in California. We also have a short video on how to use the tool. So if you're more comfortable, some people are comfortable just poking around, figuring out how it works. Some people like to watch videos. So you can kind of see that. And then we have a map where you can start by selecting the location that you work with and some additional resources. So I'm going to say pick a city here, and we have and just as a background, a lot of the climate data set that we use are gridded. So the cell size is like each grid cell is like 6 kilometers by 6 kilometers, and this is the climate data set developed as part of the 4th climate change assessment. the newer data sets that are now being worked on are like higher resolution, and we can kind of talk about it at the end if folks are interested. So when you say you put in an address, you'll get data for, the grid cell that intersects that address. But if you like select a county or a city, you'll get data for the grid cells that get data that is averaged over the grid cells that intersect that boundary. So I'm going to just type in, say, this font and search for Fontana. And so here I've selected the city, and then you click on the Generate Snapshot tool. And it moves to this next pane, and kind of gives you some options on looking at, next pane. I mean, you can work with data describing a few different climate impacts. So currently we have temperature, precipitation, and wildfire. And for each of these climate impacts, we have a few pre-calculated climate indicators, like the annual average maximum temperature, extreme heat days, minimum temperature, and warm nights. So let's look at extreme heat days. And so this interface for each of these climate indicators, you'll get the data in like two different formats. One is a chart up top, and then you have a table with some summary statistics.
Right. All right. Thanks, Shruti. Sorry to butt in like this, but the breakout rooms are going, this session is about to end. So we have another session of additional breakout rooms. So the other breakout room number 1 is on the MATES 5 data visualization tool. And then the other breakout room is on the UCLA heat maps. But I wanted to, again, say thank you so much to Shruti. This was really great. And thank you for providing, really detailed answers to the questions. We appreciated the time you spent with us today. So
and as folks are trickling in, I'm just going to go ahead and quickly present our speaker to all of you. So here to present the MATES 5 data visualization tool, we have Dr. Nico Schulte with us. He's an air quality specialist for planning, rule development, and implementation for the South Coast AQMD. I hope I got that title right, Nico. So when you're ready, go ahead and take it away.
Thanks, Sarah. So good morning, everybody. It's great to be here. Yeah, so I'm going to share an interactive website. Let me share my screen. That presents, hold on. Okay. So I'm going to share an interactive website that presents the results of our multiple air toxics exposure study. First, I want to give you some background on the study so you can better understand the website. So I'll go over what the South Coast AQMD is, and this will show you kind of why this study is important. I'll describe what air toxics are. I'll give you an overview of the multiple air toxics exposure study, or MATES. And finally, I'll demonstrate the interactive health risk data display website that we built to present the results and conclusions of MATES. So the South Coast AQMD is a government agency that's responsible for regulating air pollution in Southern California. The jurisdiction boundary is shown here in the map on the center. You can see it includes parts of 4 counties, and there's 17 million residents living in South Coast AQMD jurisdiction. So there's many air pollution sources within the jurisdiction. About 1/3 of containerized cargo passes through the jurisdiction, 1/3 of all US containerized cargo. And there's about 28,000 stationary permitted sources within the jurisdiction. So the emissions from these sources results in some of the highest pollutant concentrations in the country. So there's over 150 days in a year in our jurisdiction that exceed national ambient air quality standards. And this is mostly for ozone. And also a large portion of the California environmental justice population lives in the South Coast AQMD. So if you don't know, environmental justice communities are defined by pollution burden and population characteristics, including socioeconomic factors and sensitive population factors. And so environmental justice essentially seeks to address unequal burden of pollution on disadvantaged communities. So next, I'll briefly describe toxic air pollutants. So these are a type of air pollutants that causes cancer or other serious illness. In the South Coast, goods movement is one major source that's associated with emissions of air toxics and contributes to a large portion of those emissions. So we use a health risk assessment to evaluate air toxics. And this risk assessment generally evaluates two different types of metrics. The first is cancer risk, which for the MATE study is expressed as the number of cancer cases occurring over a 70-year lifetime due to air toxics exposure. And the second is chronic hazard index. So this quantifies the possibility that non-cancer health effects can occur due to air toxics. So if the chronic hazard index exceeds 1, that indicates that there's a possibility for non-cancer health effects due to long-term exposure to the air toxics. So next I'll go over MATES. The link at the top will get you to sort of the MATES 5 landing page on our website. So MATES, or the Multiple Air Toxics Exposure Study, this is a research study conducted by South Coast AQMD to quantify cancer risk and the hazard index due to air toxics. This was actually started in the late 80s, and the study has been updated over time and also is able to track air toxic trends over time. So the latest MATES study in the 2018 to 2019 period was actually the 5th iteration of this study. And MATES, I mean, it helps us track progress in reducing air toxics, but it also provides information to the general public about those air toxics and health risks, which goes into the data visualization that we built. So this describes kind of the major parts of the MATES study. So first, it included a year-long, well, for MATES 5, it included a year-long monitoring campaign where over 100 air pollutants were measured at 10 stations throughout the jurisdiction. It also included a comprehensive emission inventory that included all sources within all the air toxic sources in our jurisdiction. And it also included health risk modeling, where we used a chemical transport model along with the emissions inventories to develop concentration surfaces for several air toxics. And then we use that to do a risk evaluation kind of consistent with health risk assessment guidance to evaluate cancer risk and non-cancer chronic hazard index. And this provides the most comprehensive picture of air toxics risk in our region. So just a brief summary of kind of the major results. Cancer risk has decreased by about 50% since 2012. And the risk is mostly driven by diesel PM emissions. In environmental justice communities, air toxics are still high compared to still higher than the basin average. And risks tend to be highest near goods movement corridors, where you tend to have, those kind of diesel PM emissions. And in MATES 5, the hazard index was estimated for the first time, and we found that the hazard index was between about 5 to 9 at the MATES monitoring stations. And remember that a hazard index less than 1 indicates that non-cancer health risks are not likely to occur. Okay, so we need to share these findings with the general public. And so to present them, we developed an interactive website that displays the health risk data. You can access the website by clicking on the link here at the top of the slide. And I'll go into that in a moment. But just briefly, this slide kind of goes over the type of data that's included in that website. So starting in the top row here, we include data from, the measurements and modeling. We include data on the calculated cancer risks and the hazard index, trends over time through the various MAID studies, and then also data on non-air toxic pollutant levels. And on the second row, so this kind of includes resources on community characteristics relevant to understand air toxics exposure. So that includes the Cal Virus Screen 3.0 data, data on disadvantaged communities, Healthy Places Index, and green space. All right, so I'm going to pull up the data visualization and then walk you through it. Okay, so you can see, like, when we open the website, it begins with kind of an overview of how to use the data display. So you can see that there's tabs you can click on to view different types of data. You can navigate on the maps using the tools that are shown. And all the maps, you can click on them to kind of get pop-up information for more data. So the first kind of page that you see when you close that is an overview of the major findings of MAIDs. So you can see the decrease in air toxics has been about 54% from 2012 to 2018. And you can also see the average cancer risk in the South Coast Air Basin is about 455 per million. So this is like the chance of developing cancer due to exposure to air toxics over a 70-year lifespan. Scrolling down, the figure on the left gives you like a breakdown of the major pollutants that contribute to the cancer risk. So you can see from the slide, most of that risk is caused by diesel particulate matter. And then you can see the other pollutants that are contributing large portions of the risk. The figure on the right, so this breaks down the cancer risk in the South Coast Air Basin based on disadvantaged communities and not disadvantaged communities. So you can see that within disadvantaged communities, the cancer risk is about 28% higher than in communities that are not disadvantaged communities. And then finally, you can see the trends, the 54% reduction of cancer risk from 2012 to 2018. All right, so if you click on the tab at the top, you can go to the cancer risk tab. So this shows a map of the modeled cancer risk in the basin, in the jurisdiction. So on the map, you can like search for an area using the tools on the map. And then you can like click on the map to get a pop-up window that shows the cancer risk aggregated by zip code. So here the cancer risk is 461 per million. This is like higher than about 50% of the South Coast AQMD. And then you can see a breakdown of pollutants contributing to the cancer risk in that zip code. And then finally, it shows data on community information, sort of giving you more information about factors that might be contributing to that. Additionally, on the map, you can see that there are monitoring stations. So these are locations where measurements were made during mates. And you can see that, let me click on one of these. So you can see, for example, at Huntington Park, the cancer risk based on the measurements was 748 per million. And you can also see the pollutant breakdown as well. The other major sort of quantity that we looked at for the health risk evaluation was the non-cancer chronic hazard index. So if you click on that tab, you can see the hazard index is estimated at the monitoring stations based on measured data. And so there's a hazard index for calculated for sort of major organ systems, consistent with the way that the health risk assessment guidance for those types of calculations. And then the first map you see is sort of the maximum hazard index of those organ systems. And so clicking on one of the stations gives you a pop-up describing, the hazard index at that location. And then you can kind of see hazard index for different organ systems by clicking on these other tabs. So there's a large component of air toxics exposure that's related to the community characteristics. So disadvantaged communities tend to have a higher burden of air toxics exposure. And so because of that, we include other data sort of as context for these results. So this map shows the SP 535 disadvantaged communities, and you can kind of see how that kind of corresponds with where like cancer risks tend to be higher. Another tab shows the CalEnviro screen scores throughout our jurisdiction. And then we also have information on the Healthy Places Index. So this is a different type of index that scores different neighborhoods based on healthier or less healthy conditions. And finally, we have information on green space. So green space is essentially like undeveloped area that's essentially open land. And so open land tends to be associated with less emission sources, so less air toxics emissions. And so having more green space in a community should tend to have be associated with lower emissions there and lower cancer risks. So a large component of MATES is kind of to study the trends of risks over time. So if you click on the air toxics trends tab, you can see that data. And this is kind of one of the major strengths of MATES because we're able to track those trends over decades using kind of a consistent approach. So expanding this graph here, you can see trends starting from MATES 2 in 1998 through the latest MATES study in 2018, and for all the various monitoring stations. And you can just see these like massive reductions from around 4,000 to 5,000 down to where we now are at like 450 per million. And then the bottom graph shows trends in the non-cancer chronic hazard index over time. And you can also see these kind of massive reductions due to emission reductions over time. There's some tools you can use to like filter the data if you want. You can filter the map on the left to kind of filter those trend charts. And you can search on the map for your area and click on stations to filter the map. To filter these charts as well. So I mentioned earlier in the presentation that a large part of the MATE study was this CAMX modeling component, where we actually used emission inventory and CAMX to model the air toxics concentrations at 2 kilometer resolution. So this data is included here in the graded cancer risk tab. So you can see the 2 kilometer gridded data, and we've included data for the last 2 iterations of MATES. So MATES 4 and MATES 5 are shown here. So you can select the different MATES iterations. You can also select different type of data based on the calculation type. I won't go into this in detail. It's just a different sort of different way of calculating the health risks. So that kind of covers the health risk data that's available within this data visualization. So I mentioned that, other air pollutant concentrations also tend to be high in South Coast AQMD. And so the next 2 tabs kind of give you more data about those, non-air toxics air pollutants. So this first tab gives you a map of the PM2.5, ozone, PM10, NO2, and CO and SO2 concentrations, and you can look at the data for various years. So clicking on these drop downs, you can kind of go back to different years of data to see how sort of the concentrations during that year. And you can click on different tabs to see the different pollutants as well. And then finally, this criteria pollutant trends tab. So this shows those non-air toxic air pollutant data trends over time. So you can see, you can select the different types of the pollutant you want to see at the top here. And just like on the air toxics trend tab, you can select sets of stations here on the map on the left to filter the chart. So that's kind of the contents of the website. So I'd be happy to take any questions.
Martina, are you able to unmute yourself? I can try if you can't.
Yeah, I think so.
Okay.
Yeah, I just had a quick question because in the air toxic trends one kind of got me thinking about this, but I just saw this in one of the ones that you just went through right now, but was the addition of a threshold. So like the air toxic trends, is there a threshold there that could be added or that might make sense to add there? I think I saw one for one of the other ones. So it looks like some of them have threshold and some of them don't in terms of risk and that type of thing.
Right. So there's so the MATE study assesses sort of regional air toxics impacts on health, and there isn't really a threshold applicable for that. So for individual sort of facility-based or permit-based kind of studies of health impacts, there are some relevant thresholds for that kind of analysis, but this is sort of looking at the effects of all sources within our jurisdiction. And so there isn't sort of a agreed upon threshold for like, I guess what you would call like an acceptable level of that risk. Hazard index, I suppose, maybe a hazard index of 1 is sort of like a baseline threshold where, greater than 1 indicates that there's a potential for non-cancer health effects to occur. So that it's a possibility to include that here for hazard index, I think.
That's helpful.
Yeah, and for the other trends, yeah, so other pollutants do have, national ambient air quality standards that define thresholds that should not be exceeded for those. And so those do have relevant thresholds, and we do include those on the trends charts, I believe. I think I saw a question in the chat.
We do have about a minute left before we go back to the main room. So we can do that. One last question that's in the chat for you, Nico.
Okay, yeah, so this question asks how to create own map views based on data sets. Yeah, so we don't have a way to sort of overlay the various maps that we're showing within this website. So, I mean, you can do that if you, like in-house, we use like ArcGIS Pro, for example, if we wanted to overlay different maps. And you are able to, you know, access our data through that as well if you wanted to overlay those. So I think you would have to use sort of a different software tool to overlay them.
Sharing my screen. Okay. You are seeing the front page, hopefully, of UCLA heat maps. Let me know if that's not the case. What I'm going to talk about today are the UCLA heat maps, including a little bit about how we built them and some use cases, a demonstration on how to use it, and then time for some feedback and questions and answers. So the purpose of this, you know, we have several data tools in California to help us assess social vulnerability, environmental vulnerability to climate change. And we have tools that will even look at the harm of heat to communities in the future. But, you know, if you're an emergency manager working now, or a public health agency or a community-based organization working now on planning for your communities, you want to know which communities right now are being harmed the most. Even under the most optimistic greenhouse gas emissions scenarios, in which greenhouse gases peak by 2050, temperatures are still going to rise everywhere, including the Inland Empire. So for instance, in Riverside, where previous estimates from Dr. Alex Hall showed about, say, around 50 extreme heat days per year. Currently, even in the most optimistic RCP of 2.6, we're looking at 90 extreme heat days by 2040, which is only, of course, 18 years away. So, you know, it's an immediate need and it's a current need to start planning for adaptation and response for these communities. So this tool is really meant for the emergency managers, public health professionals, hospitals, mayor's offices, city planners, community-based organizations, all interested in that. So you type in UCLA heat maps. Currently, it takes you to this Google site. This is a beta version that we will someday have a better URL for this. And you click here, and it takes you to the map, which, because it's on a Google server, takes a moment to load. So you just kind of have to wait for it, and here it comes. Okay, and what you want to do is it's pretty straightforward. You have two outcomes you can look at. One is the number of daily excess ER visits, and the other is the rate of daily excess ER visits. So what does that mean? We took data from the California Department of Healthcare Access and Information, which was previously OSHPD, and we looked at all internal causes for admission to the emergency room. So that was cardiac causes, pulmonary causes, kidney causes, dehydration, as well as heat-related illness, all of which the data shows rise in extreme heat events. not just heat illness. And we converted days from May through September into heat days or non-heat days based on a system called the Spatial Synoptic Classification System. And this is a well-regarded system for examining extreme heat events that looks at the entire experience of the weather, not just the temperature. It looks at humidity, it looks at cloud cover, it looks at wind speed, and it classifies days at 4 times during the day into different air masses. And so there's like a dry tropical and a moist tropical that are the most dangerous for human health for heat. And if you pick out those DT and MT, dry tropical and moist tropical days, those are your heat days. So we looked at the number. So we start with looking at the number of emergency room visits on a heat day and the number of emergency room visits on a non-heat day. The rate then is the number per 10,000 people in the population on a heat day minus the number per 10,000 population on a non-heat day. So that is the excess rate. It's a number that many might be familiar with because we talked about it a lot during the pandemic also. So here I'm pulling up the rate of daily excess ER visits by the county. Now let's pull into looking at, we've selected our outcome. Now let's select a county. So I'm going to scroll down to Riverside. And it'll load. Here we see Riverside County outlined. I'm going to expand the picture a little bit for us, or zoom in rather. And you'll see that different zip codes are colored based on the scale of their rate of excess ER visits. So to find out what that actually means, well, first of all, we can look to the right here, and we see that we're looking at excess daily emergency room visits that Riverside County has on an average heat day, 1.1 excess visits to the emergency room for heat-related problems per 10,000 persons. But let's compare 2 zip codes. Let's pick this zip code and this zip code. And we just click on them, and you'll see that it starts to load an outline. And now we see down here those 2 zip codes. This is 92508. And I'm sorry, this is 92508. And the larger one is 92570, 2 zip codes. And it tells you that at 92508, the rate is 1.6 excess ER visits per 10,000. Compared to its neighbor, which is 3.1 excess visits per 10,000 persons. So a doubling of the rate in 2 zip codes that are contiguous, that share the same exposure to heat overall. So this really then starts to tell you about the disparities in the heat health harms. And this is where we think it becomes particularly useful for prioritizing action and allocation of resources. So for instance, in Los Angeles, the chief heat officer of Los Angeles is using these maps to prioritize the placement of new resilience centers, using this data and along with an equity index to pick the locations that are socially vulnerable, as well as having current demonstrated recent harms, excess recent harms due to heat. We also know that hospital administrators are using this up in Ventura. They can look at where their hospital is located and then look at the surrounding neighborhoods, and they can see which neighborhoods have higher rates of emergency room visits, so they can plan their outreach to those communities. They can also look at the number of excess ER visits from those communities, as shown in this table, so they can actually start to also do some more surge planning. So they can use this both for surge planning as well as for community outreach. This really adds, for those of you who know the panoply of tools that are out there, this adds to tools such as the Climate Heat Assessment Tool, which is a public health framed tool, which looks at future heat health harms. This tells you about recent heat health harms. Lastly, I want to show you a function that allows you to overlay CalEnviroScreen so that you can look at the overlay between environmental justice and extreme heat. So you can pull down this layers. I click on the CalEnviroScreen layer, and I can slide the opacity down on the daily excess ER visits. So I can kind of toggle back and forth. I had those two areas outlined. I saw that one was double the rate of the other. And then I look at CalEnviroScreen, and I see that there is some concordance, but not complete. So in CalEnviroScreen, the darker the area, the greater, the worse the score on the CalEnviroScreen. You'll see that in this zip code, there are kind of different areas of, these are census tracts for CalEnviroScreen. There's sort of a heterogeneity here, as well as in the larger zip code. So you can use this to plan, for instance, not just in that zip code, but also where in that zip code do you want to particularly focus. You might combine these two layers to help you in that regard. Okay, lastly, I'm going to just turn this off. Lastly, I just want to tell you that you can clear the data there and select new codes, and that you can download the data here in Excel and shape files, as well as JPEGs of at the county level. But you can, for those who are using the data, those who want to can use the data themselves by downloading the Excel and shape files. So I think that is what I have to say, and I'm happy to spend some time taking feedback. This is a beta version. We did this on a shoestring. We are seeking funding for improvements. And so feedback is welcome, as well as questions. Thank you very much. Okay,
All right.
Susan, I see a question.
Oh, did someone else want to ask a question?
Oh, no, I was just going to say that we were opening up the floor to questions now, and start with Susan, because I saw your hand was raised.
Okay, cool. Thank you so much. That was amazing. It's a wonderful resource, really incredible. One of the things that I'm always frustrated with in terms of CalEnviroScreen data and other data is that they're not refined enough for some of the analysis that we would like to do. And I mean, I have other questions too, but I guess the one I'll ask is, are you considering getting address level data for this? Is there any possibility of combining address level data with that? Because, for example, what we're trying to do is figure out the answer to these questions, not just about heat, but a lot of other things in proximity to industrial development. But in order to do that, it has to be more it has to be more refined than either the census level or the county level.
Yeah.
So I'm just curious about your thoughts on that.
Health data is only available at the zip code level in California. Now there is death certificate data that's available at the address level, and we do plan to we've applied for funding to look at those analyses. The numbers of deaths are much lower than the number of morbidities, hospitalizations, and ER visits due to heat. So this will be take some more sophisticated analytical methods than just looking at excess, which is a pretty raw, crude number. But we can only do this with death data in California.
Okay, thanks.
Who's next? Selena?
Hi, thank you for your presentation. I have used this tool in my own classes and also working on some extreme heat projects for my applied policy project. So really exciting to hear your explanation of all these things. And I just wanted to know if you're, since this is a beta version, are you looking to add any additional layers or data? I know that the White House just released the climate and economic justice screening tool to like label communities disadvantaged or not and address funding. Like, is that something that you considered looking into? Or if not that, what other layers are you looking to add to this map?
Yeah, so one layer that we think would be important for action is to do this by voting district. So that, right now we really want to encourage communities and citizens to look at this and say, wow, my neighbor, the leafier, richer neighborhood right next door to me has half the emergency room visits that we do, and to call their assembly person and say, what is it that you're doing about this right now? Or call their mayor's office and say, what are you doing about this right now? So you'd like to have a voting district layer on top of this.
Awesome, that's really cool. I never thought about that.
Additionally, there's been suggestions about how we can incorporate better data on Native American healthcare use. I'm not familiar with data sources available on that, but if anybody has some experience with that, please get in contact with me. I think that is probably not well represented here.
All right, we have a question from Juan, I believe.
Yes, thank you so much. My question is very similar to Selena's question as to seeing if you ever thought of utilizing the historical context of redlining and the redlining maps within LA County, for example, just to get started. A lot of the times that can influence even the way that things are consistently done now in policy, the outcomes that people are seeing now, or even changes in that type of redlining to more modernized segregation, that be through the way that city planning is done, that be through the way infrastructure is built. And so I was just curious to see if you've thought of doing that. I know it's a little bit more difficult, considering a lot of that information may or may not be available within the California level, but in the US Congress Library maybe. So just curious about that process for the racial equity aspect of what y'all are doing.
So we are actually doing analysis using this data on redlining with Lara Cushing at UCLA. I think your idea is really interesting, and I had not considered. We're doing an analysis. We had not discussed making it a layer, and I'm really interested to hear more about your idea. And I would appreciate if you have something to contribute to that idea. If you can contact me by email, that would be great, because I don't really know much about it, but it sounds like it might be a real powerful added layer.
Of course, thank you so much.
I'll put my email in.
Of course, thank you.
Are there any other questions? I appreciate Susan's comment that you can make a special request if you are a hospital. I will have to learn more about that.
I will have to double check. I'm almost positive it's true. But yes, it's really exciting to think about getting down to that granular level. How much time do we have left? Because I do have one more question if no one else does.
Please go ahead, Susan.
Yeah.
Oh, okay. Yeah, I just don't want to take up too much space, but back thinking about one of the early works in sociology of disaster was Eric Klinenberg's work on the Chicago heat wave of 1995. And in that, there wasn't a straightforward, like, oh, poorer communities are more vulnerable. It's elderly people who are isolated, and Latino communities actually did really well in that heat wave. I'm sure you know that study, but I was just curious, like when you can present like data that's raw and these kind of mapping, but how do you make the determinations or analyses that you're trying to do in terms of heat vulnerability? Like what are the metrics that you use for that? And because it's really quite complex socially, isn't it?
Yeah.
And that's a very difficult thing to get at, I would think.
Yeah.
I'm super curious about it.
So I mean, just to be clear, right? This is just looking at the raw excess visits, and it doesn't take that into account unless you bring the Calderon screen layer on top and kind of triangulate. We're doing an analysis. My postdoc is doing an analysis looking at the different indices, Calderon screen, Healthy Places Index, and how do they correlate with this outcome. And we're finding only a moderate correlation. So, these social vulnerability, to your point, these social vulnerability indices, first of all, they are kind of, they're a little bit distal in some sense from the immediate problem of just an emergency manager has to face of how do you stop heat health harms. It's a different set of issues. That's part of it, but it's not the only part of it. And it's the concordance is moderate, so you have to kind of go back and forth between them. And I think, as we saw with the chief heat officer in LA, you have to look at both. But you can't rely on social vulnerability alone, because that's not going to, as our analysis is showing, is it does not explain all of the excess heat health harms at the zip code level. So however one's measuring, whichever of the different tools California has, of which there are 4 or 5, that's what we're finding.
Thank you so much.
Hi, I have a question. I see that your interface for your mapping is focused with Google Maps. So I would like to know, because in our Inland Empire region, I think a lot of people utilize maybe our community-based organizations and government utilize ArcGIS. Yeah. So I'd like to know why you chose Google over ArcGIS or Mapbox as your platform for data visualization, please.
Well, I think it might have just been very much expediency of who knew what at the time. But we are actually changing over to ArcGIS in the next couple months. So thank you for that question, because that just validates our sense that we need to move over. And that's a plan. We've been doing this on a very, very shoestring budget. And so we have a student now who is conversant in ArcGIS, and I guess, plans to use that.
That's great to hear, because I was going to say, like, my organization, for example, recently got our organization's license. So I'm really excited to kind of be able to see what UCLA will provide in terms of the mapping information, maybe in our region or in the LA County. So it's good to hear that you guys are transitioning.
Okay, and please check back in about 2 to 3 months.
Sure, sounds good. Thank you so much.
All right, we have a few seconds.
Yes, thank you all for coming back. Thank you again to our data tool demonstration speakers for demonstrating these tools not once but twice for us, and getting us the most information that we can for these tools to use them in our daily work. So as we begin to wrap up the program, Fatima from our team is going to drop a link in the chat for a very, very quick event feedback survey. Link is right there. So I promise this event feedback survey is quick and it's based on your opinion. It's not a pop quiz of everything you learned today, but please fill this out. Take the time to do it. It helps us improve these data summit events. Every time that we do it, your feedback is very valuable to us, and also to helping us find the next topic, what we're going to talk about next. There's a lot of things to discuss. Like I said in the beginning, there was an overwhelming request for climate, environment, and energy to be discussed, and we took that feedback seriously and used it for this data summit event this time. So please let us know what you'd like to see next time. So again, the link is there in the chat for you all to fill out. So this concludes our program. Thank you again to all of our presenters in the research showcase, also in the data demonstrations. You saw on the previous slide those email reminders again, if you'd like to get involved in IE RISE, or if you'd like to get involved in our IE 2030 vision and roadmap work, please feel free to email those folks if you'd like to find out more. And again, thank you to all of you for being here, for sticking around for the full event. We really appreciate you coming out and hearing about all of this valuable information. So that concludes our data summit. Please feel free to reach out if you have questions. And as a reminder, a lot of folks are asking if we're going to see these slides or recordings. You will. We'll get it out to you hopefully within a week after we finish putting everything together. So you'll see that coming into your email inbox, but also it'll be posted on our website blog as well. So again, thank you all for coming. Please enjoy the rest of your day, stay safe, and we'll see you all again next time for our next data summit. Thank you, everyone.